Good morning, good afternoon, or good evening, depending on where you are, and welcome to today's Techstrong Learning Experience brought to you by Tetrate and AWS. My name is Cody, and I'm the host of Techstrong Learning. We've got an exciting panel ahead. First, I've got just a couple of housekeeping notes to cover. Today's session is being recorded, so if you happen to miss our discussion, or perhaps you'd like to rewatch or share with a friend, the on-demand recording will be made available shortly after we conclude our live session today. If you look to the right side of your screen, you'll notice there are a couple tabs you can use to engage with us, the first of which is the chat tab. I'd like you to start warming that up for me right now by letting us know from where you are tuning in. Right next to that chat tab, you'll see there's a Q&A tab, and that's where we'd like you to send all of your questions for today. So any questions you have for our speakers, go ahead and send those in to us, and we will answer them toward the end of our program. We do have a couple of polls that we'd like your engagement in throughout our program today, so please do keep an eye out as those will continue to pop up. And of course, before we close out, we are giving away 4 $25 Amazon gift cards, so be sure to stick around. The title of our discussion today is Deploying Microservices in Hybrid and Heterogeneous Environments with AWS, or on AWS with Istio Service Mesh. And I'm joined by Saptak Sin, Vice President of Product Integration at Tetrate, Peter McAllister, Partner Engineer at Tetrate, and Mikhail Shaparov, Principal Partner Solutions Architect at AWS. Mikhail, Peter, and Saptak, thank you all so much for joining me today. Saptak, do you want to get this kicked off?
Sounds good. Thank you so much, Cody. So let me start with a little bit introduction about Tetrate. So Tetrate was founded a few years back by Varun, JJ, Zach, and so on. So they are the primary people who created technologies like Istio. So Varun was the first PM of gRPC and Istio. JJ, while he was at Twitter, he used to run the platform team there, and that's where the genesis of Envoy started or was formed. And then Matt Klein, who's one of our advisors, he's very well known in the industry as the creator of Envoy. And not just that, even after the company was founded, we work very closely with large customers, like especially in federal space or financial services, to build a product around Istio and Envoy. And we also co-authored standards with NIST, NIST. In fact, there is a standard SP 800-204, which is the standard for microservices security for federal governments. Of course, those are also used by commercial companies. And those have been co-authored by us, specifically Zach and others. And not just governments implement those, commercial organizations and other governments also implement those. So that's a little bit about our company. So with that, before we go any further, I'd like to throw in a poll to understand where you are in your journey of Kubernetes. Give a couple of minutes. I think we can close the poll. Okay, so yeah, most of you are running applications in production, and some of you are, learning new technology. So it's a pretty close split. So I hope we have a little bit for everyone. Definitely, it's skewed towards folks who are running applications in production, and we are going to cover some of those information on this the next few slides. So, as we start on our Kubernetes journey, it's oftentimes we are coming from applications running on VMs, right? The VM was the big wave that happened just before containers and Kubernetes really took off. And not just that, many large companies or even medium-sized companies, they have various kind of infrastructure, like bare metal. They can be on various different cloud platforms. They have things in their own data center. Now, it's very hard for these companies to, in one shot, migrate into a specific infrastructure. Like it's very means, for example, if customers are migrating into AWS, it's often a multi-month effort, if not a multi-year effort. And throughout this journey, we have to make sure our customers are successful. And it becomes even more crazy when we are trying to implement consistent zero trust across all this infrastructure. We are want to make sure that the connectivity is secure and consistent again across various this infrastructure. We have a single pane of glass in terms of observability across all these various infrastructure, and all at the same time we want to ensure that our developers are not being impeded. They don't have to worry from a day-to-day perspective, hey, where is going to be where my application is going to be deployed, right? They should be, for all practical purposes, oblivious of that. And even based on availability, cost, and various other criterias, the applications should be able to move from one infrastructure to another without impacting zero trust, connectivity, or observability. So with that, I'll throw in the next poll we have around, how many of you are familiar with service mesh? There you go. I'll give a few seconds for you to complete the poll before we move ahead. Now, that's awesome to see. Means quite a few of you are running it in production. Cool. Let's move forward and discuss what is a service mesh. Now, a typical service mesh has several components, but all these components can be grouped into two main categories, so to say. One part, to think of it in very simple terms, is the agent. The other part is what is famously known as the control plane, right? Now, I often describe this with an analogy. The analogy is a home security system, right? So when you are trying to implement a home security system in your homes, typically there are two different categories of stuff that you get from the security company, wherever you buy it from, right? One is a set of sensors. It could be sensors for your door, windows, garage, you name it. If they're measuring for smoke alarms or heat alarms or even water leak alarms and so on. So these sensors are placed in every ingress and egress points for various things that I want to kind of keep an eye out for, right? Or I want to react to. But those by itself is not very useful unless you have a control plane, which is typically a box which you connect with your router, where you can set the rules for, right? You don't want, maybe during the day, if somebody is opening your door towards in your backyard, right? You don't want the alarm to go off. Only if in the middle of the night, if somebody is trying to open your door to your backyard, that's when the alarm needs to go off, right? So this kind of rules are set into the control plane, and the control plane then distributes these rules to this specific sensor so that they don't trigger things when they shouldn't be, or doesn't trigger when they should be. Not just that, even from a monitoring, if there are cameras involved or even heat sensors or temperature sensors involved, you want a single pane of glass, so to say, to be able to see all that, right? All these sensors are collecting the data, but you need to see something. So that's the control plane's use. In this case, in one of the most popular service meshes out there in the world, which is Istio, it uses Envoy sidecar proxies as those agents or sensors, which sits with your containerized application. And then you have the Istio control plane, which acts as the place where you set the rules and push out the rules, and also have some observability features. Now, as I go through this, please feel free to put in any questions you have. We have a question and answer panel on the right-hand side, and I'll save some time. We will all save some time towards the end to answer your questions. Now, Tetret provides Tetret Istio distribution, which is a hardened FIPS-compliant Istio. It's also available on ARM processors and specifically Graviton. Definitely, we work closely with the AWS Graviton team to make sure it's a really good build, it's performant, and so on. We also work closely with the ARM team. Now, we also provide 24/7 follow the sun support around Tetret Istio distribution. But to take the analogy a little more, we made it super simple to use Tetret Istio distribution, which is, by the way, upstream compliant to open source Istio. And as you saw, we have a large number of contributors to open source Istio. So we made it super simple to deploy on EKS if you are using EKS today. So right from the EKS console, if you log into AWS console and if you try to deploy EKS, there's an option for add-ons. And right from there, you can deploy TID, which is Tetret Istio distro. So we made it super simple. I hope all of you will, who are learning, and as well as those who are in production, are going to try it out and provide us feedback. We have office hours link at the end, or if you go to the handouts, that's a good way to provide feedback. Also, just feel free to email us or any channel. Go to LinkedIn and provide us feedback. Now, moving on, as I mentioned, Istio is the most widely used mesh, and Envoy is also a very popular sidecar proxy. These are both now CNCF projects. So, it's governed by the community itself. It's not, owned by any single company, but we do contribute a lot to these projects. Now, coming back to the genesis of our company and our mission of our company, right? So we want to provide a platform which takes care of with scale and complexity. What does that mean, right? So from traffic management to consistent identity to performance management. In the next few slides, I'm going to deep dive into Tetret Service Bridge and discuss how we do that. Now, as you saw, Tetret Istio distribution which is a hardened build of and supported enterprise supported build of Istio, lets you do FIPS compliance. We provide support for many more versions than the open source, right? We provide CVE patches, right? We test it closely with various Kubernetes, distros are available out there, including EKS, OpenShift, Mirantis, Kubernetes, and so on and so forth, and a few others, and so on. Now, on top of that, TSB provides you a layer which helps you for cross-cluster functionalities. We often find out, many of you said that you use Istio in production. And as soon as you start enjoying the benefits of Istio in production, it's not just one Istio instance that you have. You will often end up with several Istio instances, and sometimes customers go to hundreds of Istio instances, right? That's where, cross-cluster service discovery, cross-cluster failover, locality-aware routing, ability to do config distribution across all these clusters, being able to do continuous upgrade, and as well as cluster status reporting become really, really important, right? We were talking to Telecom a couple of weeks back, and they said that, hey, we are a large company. We have many, many Istio instances. I don't even know what services are running where. And so I have no way as a platform team to centrally ensure that, whether there are duplications of service, are there services which are not following the policies of the platform team, and so on. And so the cross-cluster service discovery, for example, becomes super, super important for such scenarios. The next part is the management layer that Tetrate Service Bridge provide on top of Istio and Envoy, right? So things like, global visibility with topology. It's a simple thing. In terms of your services are running on various clusters across the your various infrastructures, whether these are on-prem or in cloud. How do you know what's the topology of that? How these are connected? What is the latency between these various services, and so on, right? So that's what another area that we provide. Now, customers often ask us, hey, if you are doing all this on top of Istio and Envoy, do you have a performance overhead? We have, very minimal to no performance overhead because we are not in the critical path of the data plane. What we do from Tetrate Service Bridge is we program the Istio instances. The Istio instances in turn programs the or sends the configs to the actual Envoy agents. So we are not in the data plane. The Istio agents are directly connecting with each other for the communication. The Envoy agents. So we don't add a performance overhead, and we can scale really well. So with that, here is an example actually of our architecture from one of our customers. It can get pretty complex, but we can provide the consistency in terms of app security, app connectivity, observability, reliability, developer productivity across the entire infrastructure. And this is really, really important because as customers are migrating to, say, their own data centers to cloud, or even just coexisting, right? Having this kind of consistency is crucial. So with that, I'll hand it over to Mikhail.
Thank you,
Mikhail,
Saptak.
floor is yours.
For sure. That was a great overview. Thank you for that. And as you know, solutions like Istio Service Mesh or Tetrate Service Bridge, their benefits shine the best when it comes to scale. When you apply that scale, that's when it actually pays off. And it's very similar to using the cloud in general, such as AWS and our Kubernetes distribution, which is Amazon Elastic Kubernetes Service, Amazon EKS. Before we go into a discussion about EKS specifically, I wanted to see how many of you actually use EKS versus other distributions or multiple at the same time. It's a multiple choice. Please go ahead and submit your answers. That definitely provides very valuable data points to us and help us to align our strategy to better support either multi-cloud strategy or focus on on-prem, hybrid use cases, etc. I see fantastic results. EKS is leading here. It's 48%. From my own experience, I know GK is another very popular distribution on OpenShift, both on-prem and in the cloud. We also have our ROSA RedHat OpenShift on AWS offering. It is another popular distribution. Thank you for that. I'm going to close this poll for now. So talking about Amazon EKS, it's a standard Kubernetes distribution using Kubernetes API. Since many of you use it, I'm not going to focus on some of the high level. I just wanted to let you know that we run a highly available control plane. That one is scaling on its own. The charge for that scaling is not transferred onto the customers, and it's a fairly cheap offering, maintaining 99.95% SLA. It's well integrated with AWS ecosystems such as VPC networking. Pods are getting IPs as first-class citizens. Integrates with Elastic Load Balancing. You have a choice of if you're using layer 4, you can use application load balancing. If you're using if you're using layer 7 application, if you're using layer 4 TCP, we have network load balancer integrated with IAM permissions, CloudWatch for observability, monitoring, etc. And on the scalability side, there are common pain points. The scaling itself requires a strategy. A lack of scalability results in high latency. If your scaling mechanism is behind the actual demand, that's when it's going to manifest itself as high latency. Then availability can help scalability, but lack of that is also manifested in the transfer of the impact to the target, which is your customer. And that's the last thing that you want in your production system, is to expose a particular flaw to your customers. Now let's take a look at a high-level network architecture of an Amazon EKS cluster. And that is just creating a foundation to see what strategies we have to manage it at scale when it comes to networking. In a typical cluster, you'll probably distribute it across multiple availability zones. That's where your worker nodes are going to be running. You will have various peripheral services. EKS clusters do not exist on its own. They will be inside a VPC, inside particular subnets. They will integrate with probably a NAT gateway. There will be an internet gateway. You will use Route 53 maybe to expose your services to the outside world. You will use probably WAF services as well. When you talk about Route 53, that kind of works hand in hand with AWS Certificate Manager. You may use KMS, Secrets Manager. All that just shows that it's not as easy as it sounds. There is one word, Kubernetes, and there is an actual network topology that I'm showing on this diagram. So to scale it, we have a couple of options. One of them is vertical scale, so it's kind of like vertical scaling of the actual within the dimensions of a single cluster. It's going to scale horizontally, but that scalability is going to be at the cluster level. So we have a cluster autoscaler that is standard Kubernetes SIG project. Whenever you schedule a pod, if there is not enough capacity, pods will be in a pending state. Based on that event, we're going to kick off provisioning of AWS node behind the scenes. Also, if nodes are underutilized for extended period of time, we'll deprovision. We also have another autoscaler. It's Carpenter. It's fairly new. It was launched a couple of years ago in preview. Then we launched it GA. It's also an open source autoscaler. It's not specific to Amazon EKS. Can be used with any Kubernetes cluster. The benefit of Carpenter is that you can, for instance, let's say you scheduled 1,000 pods at a time, and all of them are in pending state. Now, a cluster autoscaler will start provisioning nodes one at a time. Carpenter can kick off provisioning of all the nodes. Let's say 100 nodes is enough to cover that. All hundreds are going to be kicked off in parallel, and thus you will achieve better time on the scale operations. That's great for batch. That's great for maybe distributed machine learning, for inference jobs, for spikes in demands, and things like that. However, now the question comes, is that the right way to approach scaling of Kubernetes on AWS? Let's say you're a large enterprise, you have multiple teams. All of those teams will require dev, test, prod. And is it really prudent to put all of those workloads onto the same cluster? A lot of customers do that, but many choose a different level of resource isolation. According to AWS best practices, the best way to isolate your resources within AWS is to use a separate AWS account. So if there's a separate team or a separate set of workloads, or it's a separate line of business, use a separate account for that. Those are considered to be resource containers, and they will be represented as AWS account within your AWS organization. Hopefully you're using AWS organization to manage your enterprise landscape. Over time, the number of such accounts is going to grow. While it's a great way to isolate resources, it's questionable whether it's going to add simplicity to the management and scalability over time. We provide a multi-account framework to help with that, which means that there will be a separate account for security, a separate account for infrastructure. There will be sandbox accounts, workloads accounts, and then accounts where you run your CI/CD. Still, the complexity remains, and we're going to talk a little bit about ways to address this complexity. In addition to all of that, you will probably want to have better geographical presence over time. There are multiple regions. AWS supports 24 regions. You can use them and deploy the same workloads to achieve better affinity to your customers. And that's better latency and all of the other components come with it. So it's a given, you're going to end up with multiple clusters, and you will have to deal with communication between those clusters. That's great. Maybe you solve it at the AWS level, just within the cloud itself. But AWS is not, EKS is not limited to just AWS. We also have Amazon EKS-Anywhere and Amazon EKS distro. It can literally run anywhere. It can run on premise. It can run on vSphere. It runs on bare metal. It runs on Snow devices. It's Snowball edge devices, or small devices that are produced by AWS and help edge use cases such as it's a restaurant or it's a retail store. They just want to put it in there and runs Kubernetes for them. All of that is backed by Amazon EKS distro, which is an open source, literally EKS distribution that is backing both EKS in the cloud and EKS anywhere. That's great if you solve it at that level, but what if your strategy is multi-cloud? It can happen for many reasons. Maybe you acquired a bunch of companies. Some of them were running in Azure. Some of them are running things on-prem. It could be a conscious multi-cloud strategy when some customers don't want to put all their eggs into the same basket. They want to diversify, and they want to have both on-prem presence as well as diversification at the cloud level. To solve the network topology, when you consider such complex landscape, you need an abstraction above it. And a tier 1 gateway is that type of an abstraction that is aware of that multi-cluster distributed presence and compute capacity and can manage your traffic at that level. With that, I'd like to hand it over to Peter. Peter, go ahead.
Thank you, Michal. So here we're going to show you one of 3 demos. It's a TSB setup, and what we're doing here, basically we have multiple clusters in different regions of AWS, and also we have cluster in GK. So what's happening here, call comes from outside, hits Tier 1 gateway in a cluster that placed in Canada, and then basically judging availability, call gets distributed between different clusters that have the same application. Right now, all these 4 clusters, they have the same application, but only originally 2 of these clusters, EKS and GK. So one is in the United States and one actually 2 in the United States, but one in AWS and one is in Google Cloud. They have connectivity, right? So they have capacity and calls will be distributed between 2 of them. So what we're going to show in this demo, we're going to add additional 2 clusters. So clusters already exist. One EKS hosted Red Hat. So Red Hat OpenShift hosted on AWS. It's in Europe. And another one is actually EKS-Anywhere that runs on-premise servers. So just with one simple change, we will show how traffic gets distributed to more clusters everywhere. Basically, it finds all available microservices that should respond to this specific call, and these microservices initiate calls to other services. So let's dive to the demo. This is TSB interface, and I'm going to log in as administrator. We support access to OEDBC, use OEDBC tokens. Also, we work with Active Directory. We can set up different roles, permissions, and attach these roles to existing accounts. So you don't really need to recreate your users. So if I look at clusters here, you can see Tier 1 gateway in AWS, another EKS cluster on AWS, cluster on GCP, cluster in EKS-Anywhere running on bare metal, and also Red Hat OpenShift cluster. So if, let me just touch Red Hat. If I look at Red Hat, it has 7 services running. But if I look at my dashboard, I only have 2 clusters active, AWS and GCP. So other 2 are quiet. Or we can go and look at the services, select any service here. Then I get more metrics here, more performance, errors and stuff. And also I can see that 2 clusters right now, they have 0 traffic. So why it's happening? So in the dashboard, in topology, you can see I have 3 clusters. So 2 is application clusters and 1 of them is Tier 1. So if I increase a little bit, then I can see more details. External calls coming to Tier 1 cluster and then gets distributed to 2 clusters, one in AWS, right here in EKS, and another one in GCP cluster. So now I want to add another 2 clusters. TSB has definitions that basically takes from users and distributes it to Istio clusters according to policies. So if I look at gateway settings, I have specific gateway settings and I have Tier 1. So we're working with Tier 1 right now and see there's 2 clusters right now, or I can see it in YAML form, 60% and 40% to GCP. So technically I can add more clusters here, but also another thing I can do here, just remove all of them and then traffic will be distributed equally. So let's do that. So there's 2 clusters in my YAML, and basically I'm going just to remove whole this section and apply it. And so just a little bit to explain here. What happened here, TCTL is our command line utility. Before I was working in AWS UI, sorry, in UI, in the console UI. UI makes calls to our API server, and also I can use command line client to do exactly the same thing. So instead of using a graphical interface, I use YAMLs. So let's switch back, and hopefully my generator already generated enough traffic so we can look at specific details here. To do that, we will switch to dashboard. And it's two clusters. Let me try refresh. Here we go. So I have all 4 clusters now connected. So Tier1 distributes calls between all of them. And also if I go and look at services, I can see metrics now. All services are healthy and should be the same with gateways. So one of gateways is still coming up, but everything else is already has enough traffic. So it basically showed this scenario when you have multiple clusters and multiple gateways. And now I think we can talk about other scenarios when it's more granular, if it's not whole region or whole cluster, if we're moving more on the level of microservices. Mikhail, if you can continue. Thank you.
Sure, Peter. So let's just talk a little bit about categories of failure. What kind of failure can happen? And to be honest, if anything can fail, it will fail. It's not my expression, but I like it because it's very true. There are many categories of failures that you need to plan for. And we'll talk about how service meshes in general and Istio service mesh and Tetrate Istio service mesh can help address some of them later on. So code deployments, they may fail. Something is wrong with the application itself or app configuration. It may be as bad as credential expirations, certificate expiration. It's just a bad deployment. You need a rollback strategy. Core infrastructure, of course, computers, they can actually fail. Racks can fail. Network can fail at any point. Data and state, data may become corrupted. Data needs to be replicated and backed up. Your services will have dependencies. Everything is an API nowadays, but even databases. So those represent your dependencies, and data exposes specific databases as well as other external services expose additional points of failure. There are also highly unlikely scenarios such as East Coast power grid failed entirely. So you need to have a strategy to deal with those events as well. The point of that is that resilience is a very important aspect. It should be incorporated within your tasks. You need to rehearse events, what's going to happen for those that are even less probable. Maybe it's not possible to have it implemented as continuous tests, but they should be definitely taken into account and their plans should exist. And you can think as far as the mental model about resilience as high availability on one hand, which is resistance to common failures, coupled with disaster recovery for less likely events when things actually do fail. How fast does it take for you to recover from that type of an event? And continuous improvement at the CI/CD level and requirement operational processes is an important activity to improve that area. So let's just consider just one example of dealing with failover within AWS. Let's say something on the left is represents my system that's running. Something on the right is a warm standby. That's going to be distributed across multiple availability zones. They may represent separate clusters that are running within the same VPC or different VPCs. And at the point of the failure, something failed, maybe 1 or 2 availability zones are gone now. They're not available. There will be a switch at Route 53. You can use health check driven routing. The health check is going to fail for the failed region or for the failed availability zones. It will fail over to another load balancer. and that will start serving traffic. You can achieve failover within seconds. It's possible. It's not very easy to achieve a complete no disruption operation, but we'll talk about some strategies of what you can do if you're actually running mission critical applications for that. Now, at the same time, when we talk about the multi-cluster environments and multi-cloud environments, that problem is magnified by an order of magnitude because of the east-west traffic in this particular case is not necessarily from the customers to your cluster, but it's also in between your clusters that are distributed across multiple regions, multiple cloud providers, multiple on-prem data centers. And with that, I'd like to hand over to Peter again to just show the failover use cases and how they can be alleviated by resilient strategy built in within the service mesh.
Thank you, Mikhail. So basically here is the same environment that we just looked in previous demo. And now, okay, all 4 clusters, they have exactly the same application. And I saw a question here, how we know it's exactly the same application. So TSB has ability to define application, an application that's a set of namespaces. Basically, if we say book info namespace belongs to this specific workspace or tenant, then all clusters that have book info will be assumed this application exists there. So, and right now we have 4 clusters with service running, and let's say one of microservices fails. So it's not all clusters. So Ingress Gateway is still sending traffic from tier 1 to main microservice that called product page. But then when product page tries to make a call to other microservices, one of them is not responding. So we have ability to send this traffic to other clusters. And it may be not responding because it's overloaded or it fails. It doesn't really matter. So let me switch to my demo environment and demonstrate how it works. So we have 4 clusters here. And right now, only communication between clusters is from tier 1 gateway coming to each of the clusters. So what we're going to demonstrate here, we're going to disable one of microservices called details here. And then traffic to all other clusters will go, because there's no microservice details in GCP cluster anymore. Calls to this service will be distributed to all other clusters. Please note that there's only MTLS connection between clusters. So you can see all these pod logs. So they basically signify that connection is secure and only encrypted traffic will go through. So let me switch to the console. And all we're going to do is to scale deployment for this service in this specific cluster to 0. Let's make sure that there's no details running in this cluster. Okay, so it's terminating right now. So relatively soon we will see that traffic will not be able to go to details here, and all other clusters will pick up the load. So what it will signify to us, it will be much more connections between clusters because east-west traffic configured by TSB. So what TSB does, TSB creates configuration for Istio, Istio reads it, and depending on policies and procedures you set up, configures services, microservices. So if you look at service level right now, and let's select details. So we see in general traffic is performing very well. And we interested in this one. So
obviously we need to give it a little bit more time. So I will have to refresh it a couple times. So you can see that here is a request going down. So I actually can look at service metrics for specific service. So here, details for my cluster. You see all calls going down. So GCP already not here because we don't have free services here anymore. So if I switch back to dashboard and look here, you can see now that traffic going everywhere. And because I have a little bit more history settings here, you can see that requests are going down because basically there's no more calls. Okay. Basically it. We showed that traffic travels to another clusters when it cannot end up locally. Thank you.
Yeah, so I hope it shows how traffic can travel between clusters using East-West gateway if a service is not available in a specific region or specific cluster. And I guess we're moving to the next topic. Okay, thank you.
For sure, yeah, for sure, Peter. So it's all great when your workloads are running in Kubernetes and that infrastructure is secure. It can inject sidecar proxies and also expose abstractions such as Tetrate Service Bridge at the higher level. But what is the actual reality of a typical customer journey on, let's say, AWS? When customers start migration to the cloud, they will choose certain things that they will just want to simply relocate or rehost. They will take an actual VM and move it over, put it on a host, which is an EC2 instance. Sometimes they can even use VMware Cloud on AWS and just move the whole virtual machine over and keep it running. Same happens to SQL on EC2. Some workloads may be applicable for replatforming. They will containerize them as is, even if it's a huge monolith, but it's not as bad as some others. Like maybe it doesn't handle state in a very nasty fashion. So you can really containerize it and put it to Kubernetes and take advantage of standard observability, monitoring, service meshes, etc. They'll do that. We provide some tools for that, such as app-to-container, which can discover your workloads on any arbitrary on-prem capacity, containerize them, put them into ECR, and eventually deploy on EKS, for example. And then some of them you will refactor on your right, and you will take advantage of the cloud scale and make it right from the get-go. But the reality is that you will end up with a heterogeneous landscape when some things will be running on EC2 instances, some things will be running in containers on worker nodes, on Fargate, which is a serverless option also available with EKS and ECS. And that's the reason why there is a strangle fig pattern for distributed microservices architectures, which allows you to start extracting functionality and components from those monoliths and move them gradually to the right compute platform for those services. But that also means that that monolith from which that component was extracted still stays. It's still running, and it should be part of your overall network topology. It may seem very easy to achieve that. We'll talk a little bit about what it actually means to keep that monolith running, and is it really just about that one VM that you left behind? So we provide some services such as refactor spaces, which facilitates the strangler fig pattern implementation for actual monoliths and facilitates moving the components out of the account where the monolith is running to other accounts, which will be specifically created for individual workloads. And it provides network capabilities with transit gateways and handling some of the network complexities seamlessly for the customers to facilitate that type of an approach, still preserving the appearance that the monolith is handling everything, while in reality, behind the scenes, the traffic is going to be routed to individual components in different accounts. So when you run a VM that is internal, you will have to decide where to put it. Is it public subnet or is it private subnet? And then how will clients talk to that VM? Do you want to expose it directly, which is a fairly vulnerable approach? Do you want to back it up with a load balancer? That's a cost right there. When you do that, you will probably want to use DNS. You will create a private hosted zone, register an internal domain name, put it on that load balancer. Then certificates. Do you want to use self-signed? Do you want to create a certificate authority with our cert manager? All of those concerns come into play and complicate that system. In some cases, you may take advantage of auto-scaling groups. Even putting a VM into auto-scaling group would enable some level of scalability. It's not as fast probably as doing it on Kubernetes, but it's definitely better than nothing. So with that, I wanted to also show that there are approaches that can simplify rolling out a complex network topology that includes EC2 instances, auto-scaling group, and then on top of that, there's definitely Kubernetes clusters that we talked about, and unite them with a single pane of glass, so to say. Peter, handing on to you.
Yes, absolutely. So here what we will do, so idea here, you can add microservice running as a pod and microservice running as VM. And I also saw in the chat there's a question about ECS instance, ECS services. They all can be running with the same microservice. And what's happening here, service mesh recognizes them as endpoints, microservices that will respond and provide the same visibility, same security, same traffic management. So we don't have too much time, so I will jump into the demo right now. Okay. So in this demo, instead of looking at all clusters, we just focus on one cluster. So we will look at EKS-A and see how it can use VMs as a backend services. So let's look at dashboard right now, and I'll switch from all clusters. So I'll select all clusters and just select EKS-A. So you have, you see there's 4 services, but one of them says VM. So, and VM right now running ratings V5. So if we switch to topology, we can basically see the same thing. There's a little bit of leftovers from my last demo. So you can see here, these icons look different. This one looks like Kubernetes, but this one looks like service. So basically what it means, it's VMs. And what's happening here, I have autoscaled group, VM autoscaled group, that serves as a elastic entity for services to go up and down, and we can see more or less capacity coming from the requests. But also interesting thing here is to look at combination of services and VMs. And right now, ratings service is disabled here. We can easily enable it here by, again, just previous case, we were scaling it down. We scaled down details. Now we're scaling up ratings. So, and let's make sure it's picked up in the EKS-A cluster. Yeah. So it's picked up. It will come on dashboard soon. In meantime, I would like to show you AWS autoscaled group. So to switch to my browser, so here is autoscaled group. So it created automatically right now. It has, I believe, 2 VMs. So they automatically detected and configured. So I have a script here that when instance get deployed,
So right now I have two instances here. So we basically join Kubernetes cluster and install all necessary software, and it becomes part of service mesh. So now if you're looking back into dashboard, still logged in and do refresh, we should see right now, yeah, I just need to adjust it. So you can see right now we have now it changed icon again. It's called hybrid. So we have ratings V5 that we know it's VMs, fleet of VMs, and rating V1 is a Kubernetes service. Both of them act exactly the same way. And we can get metrics for each of them and see how exactly they're performing. You see it's going a little bit down because basically traffic that was going to ratings V5 now getting divided between, so here it picked up. So gets divided between microservice and VM. And also if I go back and look here now, before it was saying VM, now it says hybrid. And I have two versions, and V1 we know it's a service, and V5 is VM. So hopefully it makes sense for your use cases to use VMs and services together, and TSB service bridge, Tetrate service bridge provides ability to combine these two different entities together in very easy way. Thank you.
So, and back to the slides, we only have a couple minutes left. So just to summarize, TSB, Saptak, do you want to talk a little bit of what we demonstrated here? Or I can cover.
Sure. Just to, overall, so as I said, in today's day and age of heterogeneous multi-cloud infrastructure, TSB provides you the ability to drive consistency in terms of security, in terms of observability, and in terms of connectivity. That's, if there's something to take away from it, that would be it. Now, of course, that is crucial for folks who want the flexibility to migrate, say, from data center to cloud, or even coexist between data center and multiple clouds. So that is key. We can go much, much deeper in any one of these topics. Please feel free to let us know. We are setting up personalized office hours so that you can have a more deeper discussion on a specific topic of your interest. Please scan this QR code or go to these URLs and you can schedule those office hours. And then also we have TID available right from AWS EKS console. Please try that out. If you want to try out TSB, again, please get in touch with us. We'll be happy to help you with that as well. And with that, let's switch over to the questions. So one question, so there's a poll. And while you are answering the poll, let's get into the question. One question that was asked was, are there any charges for TID add-on on EKS? And we answered it on the thing, but so TID add-on, you can use it for free. But when you are going to production, if you need FIPS certification and if you need enterprise support, that's when you can subscribe to TIS, which is Tetrate Istio subscription, which provides you that FIPS certification that's often required for various kind of, because of various regulations, especially if you're in financial services, healthcare, or in government. Also, we provide the 24/7 follow the sun support along with it. So that's the paid service. The other question was, let me check. The other question was, hey, can TSB also manage policies for workloads or services running on VMs? I think Peter, through his demo, addressed some of that, and the answer is yes. And again, going back to what we said, it's nobody is at a click of a switch is completely into, say, containers or containers on a just one cloud or something. It's a process, and it's a multi-year process oftentimes, and many times services on VMs coexist on services on containers, and we definitely support that. So the other question was, can we run more than one tier 1 gateway in multiple regions? Peter, you want to take that question?
Yeah, I see Cody on the screen. I think we are out of time, but what I would like to say, there's a link on the screen to schedule personalized session with us, and we can definitely dive in your use case and answer any specific questions. But yeah, short answer is yes. You can run multiple.
Cool.
If your tier 1 gateway goes down, different region picks it up.
Okay. Cody, is this, we are done, or should we have one more question?
Let's go ahead and do one more question.
Okay. And this question is, I think, for Mikhail. Are there any additional considerations or weak spots in terms of security that may open up while we focus on resilience?
For sure. I think that we didn't really talk about security as much. And, apart from standard AWS and Kubernetes controls, such as RBAC or, like IAM policies and authorization policies, etc., network security, definitely using a service mesh that can incorporate security for both ingress and egress is a huge win. We'll simplify that and minimize the surface of the attack, since you're applying consistent approach within your architecture. Using different approaches for different components will just maximize the probability of failure, including a security failure. But that's a short answer, and hopefully, if you have more questions, we're always available. Connect with me on LinkedIn, or I can join the office hours as well.
Absolutely, yeah. Sounds good.
Awesome. Well, Septek, Mikhail, and Peter, thank you all so much for joining us today. I really appreciate you being here and filling this hour with not only demos, but answering all these questions and really just making the most of it. So thank you all so much for being here.
Our pleasure.
Pleasure. Glad.
Thank you.
Thank you.
So
Thank you.
I'd like to remind everyone that this session was recorded. Following this panel, you'll receive an email with a link to access the recording on demand, or of course, you can find it living on the Container Journal website at containerjournal.com/webinars. The 4 winners of our $25 Amazon gift card drawing are Aradna C, Elton M, Monique R, and Melanie Y. So to our 4 winners, keep an eye on your inbox to claim that gift card. But if you don't happen to see that email in about the next 48 hours, do check your spam folder in case it gets filtered out. I'd like to thank Tetrate and AWS for sponsoring our program today. And to everyone who has joined us, thank you so much for being here. We really appreciate and value your time, and we also really appreciate and value your feedback. So there will be a survey that pops up on the screen as soon as we close out. Feel free to let us know what you thought about our program, or perhaps what you'd like to see on an upcoming program. Either way, we would hope to see everyone at a future Techstrong learning experience. Have a great rest of your day, and Saptek, Peter, Mikhail, thank you so much.
Thank you.
Thank you, Cody.